Welcome back. In this video I'd like to talk a little bit about inheritance and composition. Okay, the first thing to understand is I think inheritance. We're going to start with shape class, which we learned about earlier on how to develop a class. Something a little different that you probably never seen before is protected. This lets us pass variables through other classes, but not through a public view. In other words, just disallow the variables to be seen by other classes that are derived, which we're about to learn about. Okay, we have a shape class, we have a circle class, we have a rectangle class, and we have a square class. Now one thing we can look at is how are all these classes involved with each other. Well, we could say circle is a shape, a rectangle is a shape, and a square is a shape. And if we looked even deeper, we might say that really a square is just a rectangle. So we could just derive the square from the rectangle, which is a shape. Okay, so you can see how inheritance works. It passes its way down from the base, which is shape. Okay, so shape has a length and a width, which are being declared here as an integer data type for both. Okay, so what we're saying when it's protected is that it can be passed down into this derived class, and this derived class. Because here, we're using a colon and telling it that it is derived. And so when we're creating this class, we're saying that it's derived from the original base shape. Okay, so now anything that's inside of this, even if there was a public here, and it had methods inside of it, all these methods would be accessible to these derived classes. Another way to explain this in a mirror point of view would be to create an armor that would be basic, would have maybe it would hold the values of AC and AMC to decide how much defense it's going to do. Okay, so these values could be calculated later. Now, let's say we created a whole new armor, and this new armor was something, awesome. It stopped paralyzation. Okay, we would use maybe a Boolean value called non-para. Alright, so what we'd have to do was we have to create a derived class from the base in order to create this new armor. It would automatically take the original values, which were inside the base, which were AMC and AC, and it would add the ability to non-para, which is the Boolean value that we're adding to it. Okay, this is the same concept. Now, if we moved on to composition, which is a little different, earlier I showed this in my OP, Object-Oriented Programming video, how the card class might work, except for I just used the number in order to show the example. Now this time I'm going to get a little more deep. I'm going to show how composition works. It has a relationship. Okay, so one class can be used inside of another class as an object. So in other words, if you create an object of a class inside of another class, it can be used. Okay, so down here we look at deck. I'm creating a class inside the header file. This would be the header. Okay, so we're declaring everything. We have a method for creating the deck, and I'm creating an array of card objects. Now if we went down into the CPP, you could see here I'm using a for loop to keep returning cards into the deck. Okay, this probably wouldn't work. This is just a basic way to show you how it's like the pseudocode. You learned about that in my first video. This is just an example of how everything works. Okay, but we would want to keep loading. My way when I did it in the blackjack game was that I just created a copy constructor that would pass it onto a stack, which you'll learn about later. Once we learn about the other types of containers in a standard template library, things become a lot easier. Okay, I think this covers what I wanted to explain in this. As you can see here, go over it one more time. We have a card constructor. Inside the card constructor, we would decide what we're going to build. Okay, how we're going to use the variables up here. We're going to assign values to them to decide what card it's going to be. Like a card value might be, of course, we have to step through every possibility. Like we definitely want to use a loop, something that's going to be called over and over. In DirectX, there's always a main game loop, and this is the best way to learn. Okay, come down here, you can see that in my main, instead of having a card before I would have something like this. I would have the class name deck, because I'm creating an object of the deck. I'd use the word, or the letter A. This is just the way that I came up with to decide it's an object. So if it says A, then it's an object. Then you would call the method create deck. And this would automatically start looping the cards into the deck, and you would have a complete deck. Now the next step you might think about for the deck is creating a shuffle method and things like that, because you might want to deal out the same cards, or you could just randomly deal from the object, and depending on what card it is, maybe set the values within the objects to null, or something that can be recognized as not usable each time one is used. I personally would use just a stack and pop it off the stack, so that way it can never be reused, because it automatically deletes it from the stack. Okay, so what else could I talk about here? Here's another example of inheritance. I think so, yeah, inheritance. Okay, we have a person header. This is actually built and running. Okay, the whole object of this program was to take data from one file, read it in, and then print it out from another. And of course calculate everything to decide GPA, things like that. And this example is available underneath the video. Okay, it's a little advanced for what I'm trying to explain here, but we have methods like print, set name, and we have string first name, get name, last name. You can see here we're passing in both the first and the last name, so therefore we don't need to set both individually like we did for the get. Okay, then we have the constructor for person type, which we're initializing the string for first name and last name to null or nothing by using these. Okay, and then down here we declare the private variables, first name and last name, which we'll be using within the class itself or inside the CPP for person type. So come down here, you can see this. Every time we created a method, we have the person type, class name, and then the 2 colons, and then automatically the print methods and the name, set name, get first name, all these methods would pop up. You can choose what you wanted to use once they're declared inside of the header. Okay, then we're going to see out the first and last name as the method for print. Person type, set name, we're passing in the first and last name like I said earlier from the header, if you've seen here. This is the same method. You can see that was the last one I just explained. So each time we create one, we have a CPP and a method to describe how it's used. Okay, I've explained this in other videos, but I just thought maybe I'd go over it again before I get into how the derive, how classes are derived. Okay, So right here we're returning first name variable, which is created inside of our class here. So we're just returning whatever's inside of these. Okay, so of course we have the same thing for when we set it. So whatever value was when it was set is going to be put into it. I'm sorry here. Whatever was passed in was going to be set into these variables, and then we return whenever we need them. Okay, I think that explains that. Alright, so my other example was of how to virtually pass a method. Okay, so we have our person, which is the base, and then we have our derived Joe, which is the type of person. Okay, so we have different methods, run, skip, hop, lift. Okay, and we have the virtually declared method exercise. And if we look down here inside a person, you'll see that exercise is actually just calling all the other methods, which we can see each of these methods just output whatever phrase we decided to output for each. Now if you run this, you see that person constructor is called, Joe constructor is called, lifting some weights, and he just keeps going through the exercises. Okay, and the way this all works is that inside of Joe, we have recreated the virtual void exercise, which is all we really need. And if you go down and look at the CPP for that, we can see that all we really did is recreate that function. We didn't have to rewrite these functions in order to make it work, because they're already created inside of the base. Okay, that's it for this video. I hope you learned something from this. If you have any questions, you can always just post. There's a lot to learn. I know this is a lot to take in, but just try to study the examples that I gave and study these videos. Try to find other references. You know, don't just use these videos. Use as much as you can. Google's your friend. Good luck.